We've got a great topic for you today because I would guess that if you've worked with a parametric CAD software before, you've probably run into this challenge. I'm going to go over the essentials for when you have to design an organic shape or typically related to that, work with 3D scan data in SOLIDWORKS. I'm also going to include a lot of helpful resources as we go for you to go deeper into any of these approaches if you're interested. Let's start by quickly talking about what an organic model is and why they can be such a challenge. If you're at your desk and you look around, a lot of engineered products are designed with some degree of manufacturing efficiency in mind. And with most manufacturing processes, it's typically going to be easier to make parts with stuff like straight edges, flat faces, circular holes, tangent arcs, and really any other feature that can be easily defined. If you look out the window instead, you might see some trees or bushes, unless you're in a skyscraper or something. But you can see that obviously in nature, the shapes are a lot more irregular, free-formed, and curvy. So that's where that term organic comes from. But what does that mean for designing parts? Well, most CAD softwares are tailored to manufacturing, so they're great for parts that have those easily defined dimensions, but the organic parts can be a different story. I think a great simple example of this is a potato chip. Flatten it out and you could design this thing in probably 30 seconds, but throw in a couple of those compound curves and it's exponentially more difficult. So I'm going to use a different real-world example in this webinar, and I want to design a seat cowl for my motorcycle. Seat cowls are a really popular cosmetic part that covers the passenger seat to give the bike a more sporty or sort of a classic cafe racer look. The problem is they're usually very sleek and rounded and tightly fitting around the seat. So I need to start by reverse engineering my seat, and then I can move on to creating the cowl. But both of those are these curvy organic shapes. So if I gave you this motorcycle seat and I asked you to redesign it, where would you start, and do you think you could do it? At first glance, I didn't think it looked that bad. But when you kind of look a little bit deeper, the seat is full of those complex compound curves that don't have a single dimension or a reference to grab onto. So you can take your calipers to it, but you can't get that many useful values. And when you can, it's difficult to reference those values or dimensions off of something else. So that's the challenge of creating these organic shapes in a parametric CAD software like SOLIDWORKS. And it's especially bad if you're trying to reverse engineer a part and need a more accurate model. So that's our goal today, to give you an overview of some of the more powerful tools that exist for working with these organic parts. The idea here is not necessarily to do a multi-hour walkthrough of different approaches and take up your whole day. I also don't think most of you are designing motorcycle seats for a living, so I don't know how useful that would be. So I'd more like to show you what options exist and if they might work for the project that you're working on. I'll also give you the basics to get started and give you some resources on where to learn more if any of these approaches look like they're going to work for you, because we already have a lot of existing guides and videos for these approaches. With all that said, let's get started with approach number one, using sketch pictures and some surfacing. Step number one is taking your pictures, and I have a few recommendations here. First, you really want to take the time to set up good reference pictures because it's going to save you a lot of time and get you a more accurate model in the long run. But the best way to do it is by carefully aligning your camera angle to match the sketch planes that you plan on using in SOLIDWORKS. So for this first one, I'm using the top plane, for example, and I try to get directly above and use the symmetry of the seat to align my picture. Tip number two is to try some type of reference for scaling. So you can use a feature with a known dimension, but in my right view, I just added a ruler to help scale it. And we'll see how to use that later once we get into SOLIDWORKS. The last suggestion is try to use a colored background if possible. I didn't use it for this project, but if you have a solid background, you can take advantage of some auto tracing in SOLIDWORKS instead of sketching your own profiles. It works really well for something like a logo, for example. Once you're happy with your pictures, you can open SOLIDWORKS. Then open a sketch on the plane that correlates to your picture angle. So I'm opening one on the right plane and going to the sketch picture tool. Then I can import my side view picture, and I try to use the low resolution option because it loads a little bit faster. Once it's imported, start aligning and scaling your picture. So I decided to use the sort of end of the seat as my origin, and then I aligned the tabletop with my top plane in SOLIDWORKS. And this little blue line here is our scale tool for the sketch picture. So position that line where your known dimension is and apply that dimension, and then it's going to scale the whole picture based on that line and that dimension. Once I had it roughly sized up, I started trying to orient the picture more accurately using a sketch line and just kind of referenced it with the tabletop. Then I repeated that process for the top view. Same idea here, except I didn't use the scale tool. I just sized and aligned it based off of my existing picture. And I used features on the seat to help kind of line things up. I was specifically using the intersection points of the fabric seams on the seat, for example, here, and I'm going to use those again later. Then I got an above view and used a midpoint line to just try and dial in the orientation and the angle and scale and all that stuff a little bit better. The next step is start to set up your sketch profiles for surfacing. And the spline tool is really powerful here for tracing out your sketch pictures, especially when with these curvy organic shapes. It typically works really well to use more points when a curve is changing or it's a complicated geometry, and less points when it's roughly the same curve or more gradual curve. So use that spline tool to draw out the profile of the part wherever you need it. And then I ended up splitting the spline up into two halves and making the top half just construction geometry. That way I could still use it for reference, but I could just extrude out the bottom half of it with a simple surface and use that as the bottom of my seat. I'm not really worried about any of the geometry going on underneath the seat. I just kind of want a reference there. Then I repeat the process for my top view and make sure the spline is coincident on the original spline from my right view. This one was a little trickier because my picture turns out wasn't perfectly aligned, but I just tried to find a happy medium between the two sides. So I used a construction line on one side and just kind of try to take advantage of some of that symmetry. Because I'm also only going to be drawing out and using curves for one half of this seat, I can split it down the middle and I can mirror it over once I'm finished with everything. But once that profile is sketched out, I can use it to trim that bottom tray piece and get that kind of dialed in. Then I can move on to the guide curves for the lofted surface. It helps to try and plan out how these surfaces are going to be broken up and how it may make it easier to work on later if you have to make adjustments. So I decided to use those fabric seams again and break the curve up into two separate surfaces along that one main seam. And I'll use guide curves at the front where those seams intersect and one at the back where the seams intersect. So by holding Control and then clicking the front plane, I can kind of drag it out and create a new plane at that position where the first seam is at the back. And once that's dropped into place, I can drop a sketch point on that plane and then flip between the two views to roughly position it based on the sketch pictures. But I ended up actually taking some real world measurements and just tried to dial in that seam position a little bit more accurately using that instead. The picture got me pretty close, but again, I don't think my angle was perfect. So an alternative option and probably better option here is using a third sketch picture and a third angle to help dial in those guide curves. But I went ahead and kept working with this process, and I repeated the same thing for the point up front, got it set up, and don't mind some of the crazy camera work here. But once I have those points, I moved on to using the spline tool again, and this time I made sure the endpoints of the spline had a pierce relationship with the sketch profiles that I had done previously, and I took advantage of the control polygon option for the spline. And I really like this one for manipulating curves. I think it just helps you kind of dial them in a little bit better. I also mirrored the curve and made one half a construction line just to add some tangency and help me dial in the shape of the curve overall. Once I was happy, I repeated that same process for the other guide curve. And with those set up, I again wanted to split my surface up and use that main seam. So I did that by using a 3D sketch, which can be a really quick and easy approach for something like this. So I drew out a spline and then I flipped between my view orientations to manipulate that spline in the three different dimensions to roughly match the curve of the seam. The position isn't 100% accurate here because I used those measurements earlier, but the picture is still a really great reference to dial in the curve. The final piece is kind of pulling everything together with some surfacing. And I start by lofting a surface between the two profiles, and then I use the guide curves to dial it in. The first part of it looked really good, so I repeated that same process for the second surface. And I had most of the seat done now, so just had to finish up with the back part, another guide curve, and another surface loft. Then I went back and started adding some surfaces, trimming them, and just getting it cleaned up and ready to turn into a solid body. The last piece was using a filled surface to patch up that area at the back of the seat, and I used some tangency on one of those edges to capture the curvature a little bit better. And then the final last step here is putting everything together to create that solid body. So I mirrored all the surfaces across the right plane and knitted everything together to create the solid body, which looks reasonably accurate based on the sketch pictures and just kind of referencing the seat in real life. So it's really pretty impressive what you can do with just a few pictures and some basic surfacing skills. This is a relatively simple example, but hopefully it's a good one to get you started and give you an idea of how to use these tools. Now we'll move on to another approach. This one takes a bit of extra hardware, software, and some technique, but it's going to give you a much more accurate model at the end of the day. And it's great because scanners are becoming more accessible than ever right now, and even a hobbyist grade scanner like the one I'm using can get you pretty good results with a bit of patience and some technique. So like our last approach, I'll start with a few tips and recommendations for getting things set up before we get into SOLIDWORKS. The first thing worth mentioning is that scanners, especially lower end ones like the one I'm using, can have a really hard time in a couple of different areas. The first area is that we have very few distinct references. And the easiest way I can think to explain it is if I gave you a puzzle except all the pieces were the same color, it's going to be pretty hard to put the pieces together. But when you have a puzzle of like a landscape or something, for example, you can start to use references in that landscape to put the puzzle together a lot easier. So the top of the seat is a pretty good example of that. There's really nothing on the seat for the scanner to reference where it is in space, but you can remedy that by using these reflective scan markers that stick on a surface, and it helps the scanner orient itself. The second issue is with shiny black surfaces. Scanners work by measuring light that bounces back to capture geometry, but dark colors absorb light and shiny surfaces reflect light kind of unpredictably. So the bottom of the motorcycle seat is a good example of this issue. There's a workaround there too, though, which is using scanning spray. And you can even make your own, which I learned from Super Fast Matt on YouTube, and I'll play that out here.
Just mix 1 part baby powder with about 4 parts alcohol. You can be way off with this ratio and it still works, so don't worry about measuring it out. Just put your safety gear on, mix them together, and pour them into a spray bottle. You might want to use a funnel for this, or not, whatever, I'm not your dad. Once it's all in the spray bottle, spray down the whole part. After a couple of minutes, the alcohol will evaporate and you're left with a perfect surface for scanning. I do this for everything now. I don't even try to scan first, I just spray it with this stuff. 3D scanners love white powder. Use a lot. Use as much white powder as Robert Downey Jr. used in the 90s. Just don't stick it up your nose.
Once your part is prepared though, then it's finally time to do some scanning. For something like this, it's going to be really best to do 2 different scans at least, where the part is oriented differently, and then you can basically overlay those scans on top of each other. So I'm going to do one of the top of the seat and then one where I can capture some of the geometry on the bottom of the seat. You really just want enough overlapping data between the 2 scans so you can align them later. One other trick is setting up a marker-only scan first, which helps the actual scan go a little bit more smoothly. Again, just because the scanner can orient itself a little bit better. My scan picked up a lot of data from the table when I ended up going through the whole thing. So I set up a cutting plane and just erased some of that data near the flat plane. Then I got rid of any extra markers and data that I didn't need before moving on to that second scan. And same idea here, scan the markers first, then go through with the scan on the part, and then you can clean that scan up. With both of the scans done, then you can move on to automatically aligning them. In this case, the markers worked really well, again, to help align things. With it aligned, you can also do some final cleanup and tweaking of your settings. Most of that tweaking and the settings are going to vary based on what you're scanning. But one thing I would recommend sort of universally if you're going to SOLIDWORKS is dropping the number of triangles down to around 130,000. If you have a beefy computer, you can get away with more, but I've found that around 130,000 is enough to work with. It gets you the geometry that you need, but it doesn't slow things down on the computer too bad. Then it's finally time to import the scan into SOLIDWORKS. I just want to make a note here that if you're on the standard version of SOLIDWORKS, there's another webinar series that Travis Jones worked on with raw scan data, and he built out a part that way, and it's got some really great tips in it as well. But if you're running SOLIDWORKS Professional or Premium, you can use the Scan to 3D import option and the tools associated with that, which is what I'm going to do here. We also have an 11-part series going over all of the Scan to 3D tools in great detail for every tool and setting, so I won't go too crazy. I just want to show how easy this can be compared to sketch pictures. The whole reason we need these tools, though, is because 3D scans export in a file format where it's made up of tens of thousands of triangles approximating a shape. They don't have sketches, dimensions, or features like a SOLIDWORKS model does. You just have raw geometry that's difficult to modify, and not to mention it can be very resource heavy and slow your computer down. So the data is really helpful as a reference, but it's best to turn it into something more useful in SOLIDWORKS. With Scan to 3D, you can import your file and then step through the tools exactly how they're ordered on the toolbar. And so you start with the Mesh Prep Wizard, where you can use automation to help orient your scan and do a lot of cleanup work like deleting areas, patching holes, and smoothing surfaces. You can also use the next tool, Mesh Editing, to help with alignment, and that's exactly what I did. This process is really similar to what we did with sketch pictures, where you want to take the time to orient the scan. That way you can take advantage of the existing reference geometry, like having a plane go down the center of the seat, for example. I drew out a few sketches and used some geometry on the bottom of the seat to help me center and align the scan relative to my coordinate system. From there, one approach I could use is a tool called the Curve Wizard, and with that you can create some highly accurate guide curves for lofted surfaces, similar to what we did earlier. But there's an even easier option here that I can get away with called the Surface Wizard. With the Surface Wizard, I color in the areas where I want a surface and have SOLIDWORKS automatically approximate that surface for me. I took the same approach as I did earlier, where I broke the surfaces up by the fabric seams on the seat, especially because I don't want the scan data from those seams to throw off the surface approximation. And so after highlighting those areas, I went through and created the surfaces using B-splines. And it worked pretty well the first time around, but I ended up going back and used symmetry to just build out half of the seat. That way I could mirror it later. From there, it was just a matter of cleaning up the surfaces and adding some fillets. And comparing the surfaces to the original scan data shows just how accurate it ended up being after just a few minutes of work. It's always a good sign when the scan and the surfaces are fighting against each other for space in the graphics area like this. I'm a lot more confident in this model than the one from the sketch pictures, so that's what I decided to use for the last approach. Using SOLIDWORKS 3D sculpting software called Xshape, which allows us to do some hybrid modeling. With hybrid modeling, we can easily go back and forth from 3D sculpting, where we have a lot of freedom, and then switch back into actual CAD modeling in SOLIDWORKS, where it's easier to work with those defined dimensions and features. The reason that's a huge deal is because most sculpting softwares work with meshes, and they typically export STL files like our 3D scan from earlier. That means the part is made up of tens of thousands of triangles, which makes it really difficult to work with in a CAD system. But with Xshape, you can import and export SOLIDWORKS files with their coordinate systems and reference geometry intact. So let's circle back to the motorcycle seat cowl, and you should get an idea of what I'm talking about. At this point, we've built out a reliable CAD model of the seat, and now I finally want to move on to creating that cosmetic seat cowling. I start by setting things up first, and I imported my CAD file of the seat that I created in the last section so I can have a 3D reference to model the cowl around. And then I also imported a side view picture of the motorcycle just to help visualize things as I'm building out the cowl. And I scaled and positioned that picture around the seat model, which actually ended up matching up very well. So that adds some confidence that we got things right with the 3D scan and with the model. And then there's one last reference to add. A guy named Charlie Trelogan wrote a great article for styling certain motorcycle features, and in it he describes the swoop. The idea that you want your seat and gas tank to look like they belong together by making the curve of the tank flow into the cowl. So with my picture from earlier, I can use some familiar SOLIDWORKS tools in X-Shape to open a sketch and roughly draw out that curve with a spline. Then it was finally time to move on to the sculpting part. You start with what's called a subdivision, and it's essentially a piece of clay with adjustment points attached to it. You can push and pull on those points, edges, or faces to mold out basically the shape that you want. And you really want to start with as few adjustment points as possible in the beginning, rough out your shape, and then you can add more points and edges as you go if you need them. For a part like this, a symmetry plane is also very helpful, and that just means anything you do on one side will happen on the other side as well. And then one other commonly used tool is a crease like this, where you want a hard edge to be, it will fold it over essentially right there and give you that hard edge. So from there, it's just a matter of molding out what you want. And I ended up playing around with that for quite a while, just trying different curves and shapes. And at this point, I decided I needed another adjustment area. So I added an edge loop just to give me a bit more control. So that's kind of what that process looks like. And then further on, I could see that my cowl wasn't formed around the seat very well. So I made it transparent just to get those areas formed out a bit better. And then I kept working on things. And again, I had no idea what I wanted from the start of this, but I ended up with something that was sort of a cross between a cafe racer cowl and a more modern sport bike cowl, which works pretty well because that's kind of what this motorcycle is anyways. But once I was finally happy with that shape, I exported it as an SLD XML file that I could open in SOLIDWORKS and do some final cleanup, like indenting the shape of the seat from the cowl and giving it a small offset just to help it fit a bit better. I have a few other ideas for the seat, but I'm going to end the design part here just so I can talk about a few other resources. We have a few XDesign YouTube videos, but the best resource I found by far for getting started with XDesign is Solid Professor. Solid Professor is sort of like YouTube, except for falling down a rabbit hole there, you get certifications and not a bunch of cat videos. It has step-by-step guides for all kinds of engineering-related topics, but more specifically, SOLIDWORKS, Mastercam products like we're working with here. And a lot of the stuff that I've gone over today is covered in detail on Solid Professor. It's a really cool product that we actually work with. So if that or really anything we've gone over today is something you'd like to try or know more about, feel free to reach out to us and we'll try to get you some more information and see if it's a good fit for you.